Fifth grade Excel, lesson number 45, recognizing when figures are similar or congruent, recognizing flips, slides, and turns, recognizing lines of symmetry, and recognizing bilateral and rotational symmetry, and recognizing the symbol for a triangle. Now most of this should be, review for you, other than this right here. That's going to be brand new, and everything else should be pretty familiar looking to you. Two figures that are similar have the same proportions but are not the same size. Now that probably doesn't mean a whole lot to you, so I'm going to show you what that means. Each pair includes two similar figures. The symbol shown below between each pair, which looks like this, means is similar to. So this shape is similar to this shape. Notice that the shapes look exactly the same, only this one's smaller. That's what a similar shape is. It looks like they took it, put it on a copy machine, and shrunk it down. They threw it in the dryer for too long and it got a little bit too small. And so we have similar figures. This shape and this shape look just like each other, only this one's a little bit bigger. Similar figures. This shape and this one shrunk down to that one. What is not a similar figure? If I have this square and I put something that looks like this, these two are not similar to each other because this does not look like that one, only larger. Two figures that are congruent have angles and lengths and sides that are identical. Each pair shows two congruent figures. The symbol be shown between each pair, which is an equal sign with a little squiggly thing on top, means is congruent to. So this shape is congruent to that shape. Congruent means exactly the same. Not shrunk, not enlarged. These two are the same, they look the same, and they're the same size. Now you could twist one of them. You can move it into a different spot, but it has to be the exact same shape. And here we have this one and this one congruent to each other, and these two congruent to each other. So you need to understand on this part of the lesson the difference between similar figures and congruent figures. If a figure is moved to another position, the change is called a transformation. You can transform a figure with a flip, a slide, or a turn. A flip is also known as a reflection, like when you're looking at yourself in the mirror. A slide is a translation, like when you take a language and you change it into your language, you're translating that. And then a turn or a rotation, like when you rotate a doorknob. A flip or reflection occurs when a figure moves across a straight line in such a way that the new position is a mirror image of the first position. The new position is the same distance from the straight line as the original position. So you can see we have this little straight line. That's like the mirror. This is the same distance away from that line on both sides. And this shape right here and this shape here are mirror images of each other. It's like we took this corner and we flipped it over to there. That's a flip or a reflection. A slide or a translation occurs when a figure moves without changing its appearance. Each of these shows a slide. So from here to here, this is a slide, and here to here, that's a slide. Notice there's no flipping going on, there's no twisting going on, it's just sliding it straight across. A turn or a rotation occurs when a figure turns around a point. So if we have this shape here and we spin it around like that or spin it around like this, either way, we get this other triangle, which is the exact same shape, only it's been twisted, it's been turned, it's been rotated. Here's another one with this square being rotated around this way. There you have a turn or a rotation. A line of symmetry is an imaginary line which divides a figure in half so that if you were to fold the figure along the line of symmetry, the sides line up exactly. The two halves would be mirror images of each other. These figures show one or more lines of symmetry. Here's a rectangle. This is the shape of your Excel paper that you're looking at right now. We can fold your Excel paper right down that way, which we do all the time. Just stick it in your binder or whatever, and both sides match up. You can also fold it long ways, which we really never do, but the top would line up with the bottom part of your Excel paper. Now what you cannot do, as it shows over here, is fold it along the diagonal. And you might want to try that right now. Try to take your Excel paper and fold it from one corner to the other corner and see if these two corners actually match up with each other. Actually, most kids have a very difficult time even folding it on that diagonal. It really throws kids for a loop. But this corner is not going to match up with that one. You can kind of see, just by looking at this picture, if I folded it, this corner is going to kind of stick out over here. It's not going to end up being way down over there. Here's a flower with a line of symmetry. There's many lines of symmetry in here going through the middle of the petals. We can even fold it between the petals right here. These three petals line up with these three petals. That shape has many, many lines of symmetry. Now a square does have diagonal lines of symmetry. You can fold it this way and this way, but you can also fold it diagonally, and this corner over here is going to match up with that corner over there exactly. You can take a square, if you have a square piece of paper, like a little post-it note, it's a perfect square, and fold it along the diagonal and see that it does line up as a line of symmetry. This is also not a line of symmetry. If I folded this over, this triangle would look like that when you folded this on this line, so it does not line up with the other triangle. A figure has rotational symmetry when it can be rotated to one or more positions before turning 360 degrees around its central point and still look identical to the original figure, can cover itself completely. The order of symmetry indicates the number of different positions to which a figure can be rotated to match itself exactly. If there is at least one rotated position, then the original position is counted too. Regular figures have an order of symmetry equal to their number of sides. Remember what regular figures are, like a regular octagon or a regular pentagon. They look totally like every side is the same size, every angle is the same. So all you have to do on those is just count the sides, and that is the number for the order of symmetry. For example, a square has an order of 4, a regular pentagon has an order of 5, and so on. So this can be a little bit confusing, but hopefully you'll get it. This letter A, if I try to rotate it around on its mill, it's never going to look like the letter A until it gets back to the beginning, back to the original position. So I'm going to say that this has 0, and I put a line through it so you know it's not the letter O, a 0 order of symmetry. Now this letter N, as I rotate this around, or the Z, it depends on how you look at it, as I rotate this around, it's going to look the same when it gets upside down. So this N, if you flip it upside down, still looks like this. They look the same. So it's going to come around to one position that looks the same, and then we count the original. When we can do it one time, we're going to count the original as well. So this has an order of symmetry of 2. This triangle, with the arrow pointing down, you can see if you were to rotate this around. In fact, let me pull up a triangle and show you how this works. Alright, I just pulled up a triangle to show you how we can rotate this, and you can see I'm going to start it. Okay, here's what this triangle right here looks like down in number 9. Oops, okay. So it's kind of pointing, let's do this, it's pointing down that way. So as I rotate, and my triangle is not a perfect regular triangle, it's a little bit off, but hopefully you'll get the idea here. As I rotate this around, you can see that right here it's going to point down again. It looks exactly the same as it did at the beginning. And then I go a little bit further and it's going to point down again and look just like it did at the beginning. And then back to the original position, which is right there. And so that has an order of symmetry of 3. Because every time I turn it, it looks the same, right? 3 times around. Now here's a pentagon. I want you to answer what the order of symmetry is there for number 10. Pause the video, turn it back on after you have the solution. Alright, what you should have chosen, and I'll pull up a pentagon here. Here's a pentagon. Let me see if I can make it totally regular size. This is kind of tricky to do. Do all the sides look the same? I don't know. Let's leave it there. Okay. What's the order of symmetry of a pentagon? Well, notice how it looks right now. You've got the bottom line like a house. It kind of looks like a house, right? So I go like this. There's 1, still looks like a house. 2, looks like a house. 3, looks like a house there. 4, looks like a house. And 5. That is the order of symmetry on that. So you were to write the number 5, including the original position. All right, the symbol for referring to a triangle is a small triangle and the labels of the points. So this triangle right here is named as triangle BCD. BCD, triangle BCD. That's how I name a triangle. If I have this shape here and I put an A, B, C, D, E. If I want to talk about this top triangle, I write triangle ABC. If I want to talk about the bottom triangle, I can write triangle CDE. That refers to this triangle right here. So this is how we write a symbol for the name of a triangle. That's it. Thanks for watching.